Hello students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is simplify and write as a single log term. In this session, we will be taking up 3 questions. We will be solving 3 questions. In each question, we will be having one expression which has to be simplified. And of course, the expression will be containing log terms. And along with the log terms, the expressions may contain integers, pure integers as well. Okay? And using all the properties, the relevant properties from all the properties of logarithms that we have learned so far, we will be simplifying the expressions given, and we will be giving the final answer or writing the final answer as a single log term. Okay? So without any further delay, let us start with our today's session. The first question says half times log of 25 to the base 3 plus log of 4 to the base 3. We have to simplify this expression and give the answer as a single log term. So we see there is this coefficient over here which can be taken to the power of the argument. So it becomes log of 25 to the power of half, and this is to the base 3 plus log of 4 to the base 3. And what is 25? 25 is 5 square. So it is 5 square raised to the power of half. Therefore, this will be log of 5 to the base 3 plus log of 4 to the base 3. Now we are having 2 log terms to be added together which have the same base, so the arguments will get multiplied. Therefore, it is log to the base 3 and the argument is 5 times 4, or it is log of 20 to the base 3. This is our answer for the first question. Coming to the second question, it is 3 minus log of 10 to the base 4. Now this 3 is a pure integer. This does not contain any log part. And we do not know of any property which connects an integer to a log term. So we have to introduce, or we have to write this number 3 in form of some log term. We have to write some log term which is not visible in this term 3. But we have to make it visible. How do we do that? We can write 3 as 3 times 1. So it is 3 times 1 minus log of 10 to the base 4. And this 1 can be written as, because the other term is having the base 4, so we write 1 as log of 4 to the base 4. Because we know log of a to the base a is always equal to 1. So we are using this property, and since we need the base 4, we have taken this 1 to be equal to log of 4 to the base 4. Okay, so in place of 1, we can now write 3 times log of 4 to the base 4. So now we are having this log part in this term which contained only an integer. Minus log of 10 to the base 4. And 3 is the coefficient, so it can be taken to the power place or power position of the argument. So it becomes log of 4 to the power of 3, and this is to the base 4, minus log of 10 to the base 4. Again, these two terms are connected by, and 4 to the power of 3 will be equal to 64. So it is log of 64 to the base 4 minus log of 10 to the base 4. And these two terms, they have the same base 4 and they are connected by this minus sign. They are getting subtracted. So the single log term will be to the base 4 obviously. And the arguments will get divided, the first argument divided by the second argument. So it is log of 64 over 10 to the base 4. And what is 64 over 10? It is log of 6.4 to the base 4. Or we can cancel both the numerator and the denominator by 2. And we get this as log of 32 over 5 to the base 4. So both are valid. You can write any of these two. So we have given the answer as a single log term. Coming to question number 3. Half times log of 1 over 49 to the base 2 plus log of 21 to the base 2 minus 2. Now this time it is containing, the expression is containing 3 terms. Previously, in the previous 2 questions, we had 2 terms, but in this case we are having 3 terms. And the third term is a pure integer, so we have to write this as 2 times 1 because we need a log term in every term of the expression. So what we do is, in place of 2, we write 2 times 1. And how do we write 1? Because the other terms, other log terms are having this base 2. So we will be writing, in place of 1, we will be writing log 2 to the base 2. And what is the other modification that has been done? This half is in the coefficient place. This has been taken as the power of the argument for this log term. It is log of 1 over 49 raised to the power of half to the base 2. And the second term remains as it is, plus log of 21 to the base 2, and the third term becomes minus 2 times log of 2 to the base 2. Because log of 2 to the base 2 is equal to 1. Okay? And then we are having, and what is 1 over 49 raised to the power of half? It is equal to square root of 1 over 49. A power of half is square root. So it is square root of 1 over 49. Okay? So it will be square root of 1 over 49 will be 1 over 7. And we have log of 1 over 7 to the base 2 plus log of 21 to the base 2 minus log of, this time this 2 is in the coefficient place, which is getting transferred to the power position of the argument. So we have minus log of 2 squared to the base 2. Now these two log terms are connected by this plus sign. So you can do in 2 steps. First of all, you join these two, you combine these two. The arguments will get multiplied. The base will be the same. The base remains as 2. And then you get a single term, like a single log term. You will be having log to the base 2 and 1 over 7 times 21. So that will be equal to 3. So it will be log of 3 to the base 2 minus log of 4 to the base 2. Or is over here I have combined them in 1 step. If you think you will be doing some mistake, you combine them in 2 steps. Okay. So where in place of plus I have written multiplication, and in place of minus I have written division. And 2 square is written as 4. Okay. And the multiplication and division, they both enjoy the same priority. So whichever comes first, we will be doing that one first. We will be doing that operation first. Okay. That is the rule of simplification. So we will be doing this multiplication. 7 times 1 is 7 and 7 times 3 is 21. And this 3 is now getting divided by 4. Okay. So it is log of 3 over 4 to the base 2. Okay. So this is the single log term which represents this entire expression containing 3 terms. Okay. So this is how we simplify logarithmic expressions. We will be having more number of sessions, at least 2 of them, at least 2 more we will be having. I don't remember actually, 2 or 3 more sessions we will be having on the same topic, simplification of logarithmic expressions. Okay. So let us stop over here for this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.